So hopefully this is recording. I am doing this video because I just finished grading the big quiz we had. It was the point-wise, it was the biggest quiz we've had all year. It was only really on two subjects. Some of the kids did pretty well, but a lot of them are still struggling. So I'm going to give them a quiz Wednesday. I say quiz, I call them exit tickets. They are much shorter quizzes, basically. And they have the essential questions, we'll call them. So it doesn't have a lot of the more difficult questions. It has the very basic questions that they have absolutely got to know how to do. So I'm going to do this video and go over every kind of question they are going to see. It's probably only going to be 4 questions. So they think that's great. But the problem with that is if they get one wrong, then they're already down to a C, depending on whether or not they get partial credit. So the first kind of question that was on the last quiz I just graded and that will be on Wednesday again is conversions. They need to know how to convert measurements, units, and they need to know how to use proportions to do that. So I got a couple of messages, why can't we just do it this way? The kids ask, well, why can't I just do it this way? This way's easier. We have specific standards on how they need to solve things. There are some standards where they can just solve it however they want. This particular standard requires the use or really the understanding of proportions. So they have to know how to use proportions for this standard. The next one you see doesn't. It uses a formula. So they can use the formula for that. And frankly, for that one, they can probably do it any way they want. They could even use proportions for that. Proportions can be used for everything, though, in this whole unit that we're on right now. That's why I'm really making sure that they understand that. So for conversions, if they get a problem like this, and there was one pretty similar to this on the quiz and similar to this, they're all pretty similar actually. There's a process I gave them in class. I'm not going to show you on the screen. They should have it, but I'll say it verbally and then you can write it down. But step one, they need to find the two measurements that are in the problem and just underline them, highlight them, whatever they want to do. These two measurements. I'll go ahead and do the bottom one, just sort of save time. This is what they are then going to look for. So now we're kind of on that step one. Step two, they need to find those measurements on their reference sheet. So this is the 7th grade reference sheet. I don't know why that just happened. 7th grade reference sheet that they will get for the EOC. They're allowed to use it in class. They use it on the quizzes. They practice with it, but they have this. So I need to find, so I'm going to go back to the first problem. I need to find liters and milliliters in one conversion. Hopefully it's in one conversion. It's not always in one conversion. Sometimes you have to do 2 conversions, which I'm not going to try to do in this video. That was on the big quiz. It is not going to be on Wednesday's exit ticket. So I need liters and milliliters. Well, feet, inches, none of this stuff. That's all our customary measurements in the United States. So let's go to metric. Well, that's meters, not liters. Meters. Here we go. Right there. Liters and milliliters. Oop, didn't want that. It does not matter what order they are in. The kids sometimes are looking for it to be in a specific order to match the word problem. As long as those 2 units are in the conversion, they're good. Some of the conversions are actually duplicated. I'll just show you. We have feet to meters here, but then meters to feet. That's when they can pick the one that works the best, but sometimes they don't have that. This is the only place with liters and milliliters. So they have to know that's the one they use. It doesn't matter which one comes first. So now to set up a proportion, it's pretty straightforward. We've done this over and over again, but some of them are not following the process, not practicing it. I just write the conversion with the words. This is the part that they're not doing. They are skipping this, and then they're messing up the second part. So I write the words, liters. It's really difficult to write on this using a mouse. Liters, and then the bottom of the fraction is going to be the 1,000. So again, I'm just taking the 1 here, the 1,000 there. but they are not writing the words. They have got to do that or else they are going to get confused. I'm going to write out the whole word. Actually, I'm not. I'm just going to abbreviate it to milliliters. They could just put L up here, and that's what I told them in class. They can use the first letter of all the conversions to save time. That is the first fraction. That would equal, and I'll write this again with the abbreviations maybe. That is going to equal. Now they just have to write the same units up top. So I will just write L there and ML. I'm not even looking at the numbers in the word problem yet. Just immediately write the units over here to match. Liters are on top, liters are on top. Milliliters on bottom, milliliters on bottom. Like I said, we've gone over this, very straightforward, but they're not practicing it and they're not using it on the quiz. So now I go back to the problem and I just find the number. Well, there's the number. Well, what measurement is that in? Well, it's in milliliters. So the number goes on the bottom. That's why they write the units first, because then they know immediately where to put the number. So 5 and then 6. Now I'll solve this one. I'm not going to solve all of them. So we've done this in class again. I will kind of color coordinate. They do what's called cross multiplying, or we kind of call it the butterfly method. That's one butterfly wing. This is probably going to mess up. That other one tried to mess up on me. There's the second butterfly wing. So again, that's why it's called butterfly method. Kind of looks like wings. Now here's where they mess up in solving. They try to solve in the middle of the problem. They need to first set the equation up. So I'm going to come way over here. Inside of the wings, inside of the little circles, we multiply those things together. So 1, this means multiplication, 8,456. So we multiply those two things together. They do not do that math. That's what they keep trying to do, is they do the math too early. They need to set an equation up first. So we say that equals, in class, I tell them the two wings equal each other. Like if you look at a butterfly wing, they're the same. They're identical. They equal each other. So first we need to set the two wings equal to each other. So that's the blue wing. Here is the green wing. Oh, I totally messed up. I forgot to finish the problem. So if there is a blank, like we don't have anything in this wing right here, that's your variable. The last thing, the blank thing, when you're doing conversions at least, is the variable. So that's what we're solving for. I was thinking that was a number, but that's the letter L. This L stands for liters, just like that. Liters and liters, milliliters, milliliters. So I forgot the variable. I've told them over and over again, wherever your blank is, that's the variable though. It's always what we're solving. How many liters is always going to be the variable, whatever the question is. So down here, the variable will be how many centimeters. So X will stand for how many centimeters. So now we can come back up and finish it. So this is 1,000. I don't need to write the units when I'm solving. That's just to set it up. 1,000. And again, that means times X. So now they solve, but they solve going down. When we solve equations, we always solve going down, not left and right. And we'll have a whole unit on equations later. I'll just go to black to solve. 1 times 8,456 is just 8,456. So I'm going to probably just, yeah, that actually came out okay. I could have typed it. Now I have 1,000 times X. Well, that's just 1,000X. We can't do any math if we don't know what X is. So all we can do is write 1,000X. If there's no symbol there, that just means we're multiplying those two. Now to solve, last step, and this is pretty much always the last step in conversions, we need to get rid of the 1,000, and we do that by division. If we are multiplying 1,000 times X up above, the way we get rid of the 1,000 to get X all by itself, because I tell them that's basically what solving an equation is, you're just trying to get the variable by itself, we need to get rid of that 1,000. Well, the way we do that is we divide in this problem. That divides out and goes away to 1, basically. Well, whatever I do on one side, and they are pretty good with this rule, whatever you do on one side, you have to do it on the other side. So that means I now have to divide by 1,000 over here. And when I do that, that gives me x all by itself, which is the goal. And then if I divide this out, that is 8.4, and they need to make sure they get that decimal. Some of them kind of did the right steps, but then didn't put the decimal in the right place. So that's my answer. Now, if they don't know what they just did, if I ask, well, what is the 8.456? All they do is they come up here. Oh, well, that's 8.456 and then liters. That's the L is liters. So this means that I have 8.456 liters. I'm going to keep going fast. You can always rewind. Let's do this one now. Again, I need to find these two measurements on my sheet. Not up here because this is all like within, this is all United States to United States. This is rest of the world pretty much to rest of the world, metric. Down here is United States to metric, customary to metric. So that's where inches to centimeters will be. Well, here it is right here. Inches, centimeters. So that's the one I use. I could use this one. It has centimeters and inches also, but if you use proportions, it doesn't matter which one you use, which is why I'm trying to get them to use proportions because it fixes a lot of stuff. So the first fraction is 1 inch over 2.54 centimeters. I'm going to abbreviate. So 1 inch, I will put an N because that's a little confusing, over 2.54 centimeters. And I'm going to do cm for centimeters. So that equals, now again, I just go ahead and I make the fraction with the units. Inches is on top. And when they skip this, this is when they mess up, especially in percents. A lot of them messed up. So centimeters and centimeters. Now I just come over here. Well, where's my number? Well, there it is. What's its measurement? Inches. So it goes on top. And that's all I'm going to do. If you cross multiply, so the variable, the blank will be down there. So I can put that. If you cross multiply, you basically wind up just multiplying these two to get your answer. All right, so the next kind of problem was percent problems. And there's a bunch of those. So I'm going to try to do a few. This one's a little trickier to set up, but I'm going to change it for the people that are struggling. I mean, we did this in class, but I'm going to kind of tell them do it this way. Because of some kids, by the way, tried to do what I'm about to do in all of the problems. Conversions cannot be done this way. You have to create the first fraction using the conversion from the sheet. Percentages, though, we said in a percentage proportion, there's always going to be a variable, x, just like in conversions, but there's also always going to be a 100% number. Like literally you're going to put 100% in every single proportion because percentage literally means out of 100. That's what percentage is. So every proportion is going to have 100. Let's go one more percent in it. So because of that, and we talked about that and I showed them how to do it, but some of them that struggled, I think, need to kind of force themselves to do it this one way. We're going to start with 100% in every problem. If they're struggling, if they did okay on the quiz, then they don't have to do it this way. So if I know it's about percentages, so right here, it says percent. As soon as I see that, I know this is about percentages, I'm going to write 100%. And again, they still have to know how to set up proportions. There are other ways to do this, but they have got to know how to do this. So we're going to, oh, I knew I was going to do that. Don't know why sometimes it goes way off. I don't have a touch screen or this would be way easier. All right, so we're going to start with that. On the other side, we're going to go ahead and make our fraction. Again, I've given them this process and they're just not following it. They're skipping steps and they're messing up when they do that. Even some of the ones that kind of know what they're doing. So now I have two options. This 100% is going to need another percentage. Every proportion has two percentages. It has the whole percentage, and this is like, you know, out of the total number of points, what percentage is 18? Out of the total number of views, what percentage is the likes? Out of the original price, what is the discount? So this is about a discount. Yeah, on sale. So it's about a discount. So the out of price, the original price, the original number, the first number, all of those things are the 100% number. And again, we talked about that in class. I gave them a little sort of cheat sheet that they were supposed to copy down about like what words will tell you which number is the 100% number. So it was these kind of things. If it says original, that's automatically going to be the 100% number. If it says initial, kind of same thing. If it's the before number, so like if there's kind of a chronological thing that happens, the before number, the number that comes first, basically. What's the basket? Oh, if there's like a total number, like that's sort of the out of, and I'll give you an example of above. So Jordan's points are 18 points out of a total of 72. So the 72 would be the 100% number. That's all I can think of off the top of my head. Let's make that kind of red so we know it's not part of the problem. I mean, it is sort of, but so that's probably where the kids are struggling the most, is figuring out which number is the correct number to match up. Now, here's what we need to do. And this is the next thing that they kind of were struggling with, some of them. I need to match up this 100% with two things. And when I say match up, these two things have to be above and left or right. Above, below, left, right. Always. They cannot be over here, basically. One of them is the percentage sign. So I told them that there were multiple ways to do it. If they're struggling, though, I want them to go to this method. Go ahead and write. I don't know. We'll go to this color. Go ahead and write percentage up here. This is the way the book taught it. And we went over the book way, and then we went over another way. If they're struggling, though, just go ahead and put the percentage up there. This number over here, this spot right here, this is going to be one of these numbers from the problem, and they have to figure it out. It's either the first number that would have happened in chronological order, and we talked about that in class. That's the before number. If it says original, that's pretty easy. The original number goes there. It may be a variable. So like, for example, if they say, what is the original price? Well, the question is always the variable. So if they're saying what is the original price, then the variable is the thing that would go here. So again, percentage needs to go above it. The number that is the original number, the first number, the total number, the out of number, that needs to go to the right. And again, this is not the only way to set it up. So if they know what they're doing, there are other ways. All right, so now I don't have a percentage. It says what percent right here, what percent. That means that's the variable. I'm solving for the percentage. So I can just go ahead and write X here. Whatever you are solving for, whatever the question is, that's the variable. It tells me it's going to be a percentage that I'm solving for. So I already have X there. Now I've just got to figure out where do the 18 and 72 go. And again, the total is my keyword, or you could think of this as the out of number. It's 18 out of 72. So that number needs to go right there. So that, again, has to match up to the right of the 100. It cannot go up here. And that's what some of them were doing. So I put the 72 here. Why is that not working? That's good enough. 18 up here, because that's the only spot left. I have the 18. So now they cross multiply to solve. And again, there's another way to do it, which I did let them do some problems however they wanted to on the quiz, but they are going to need to be able to set this up on the exit ticket. And then they can solve it actually however they want. So really quickly, I'm just going to do a few more. Again, that's pretty easy. It literally says out of 600. That's going to be my 100% number. So quickly, 100% goes in the bottom first. Create, and then and they need to be doing this because a lot of them are mixing up the numbers with the percentages. They need to write the percent sign so they know which things are percentages. That's going to equal. Now I'm going to save that for the numbers. Well, if I have a percentage, then I can go ahead and write that percentage here. Like if they've given me a percentage, that'll be the only number that could go there. If it says what percent, then that's what I'm solving for, just like the first one. So that's got to be the x. So the percentage is normally really easy to fill in. It's this side that's tricky. So I say, okay, well, what's my total, my out of, my original? Like what is it? Well, this one it literally tells you right there, out of. God, I don't know why it does that. Out of 600. So 600 is that number. And then the only other number I have left to fill the spot is the 450. So this one was pretty similar to the problem right above. Down here, this one was a little trickier. There's a last step. I'm just worried about them setting up the proportion. Pair of sneakers costs $80, but I know it's about percentages. If I see percent, I know it's about percentages, so I can start with 100%. I think I'm yelling at you guys. Get very excited about math. Now I know this is going to be percent. Well, like I said, if they give me a percentage number, that has to go here. No other options. It's the only place it can go. Well, the way I'm teaching them, there is another option, but the new way that I'm teaching them to make sure that they all can get at least most of it down. Now, what is my total number, my before number, my first number, my starting number, my initial, my out of, whatever you want to call it? Well, if I think about the problem, the original number, it doesn't say original. Sometimes it will. But if I think about the problem and it tells me here, what is the sale price? Well, the sale price would be the after price. The original price would be my starting price. So I'm going to take money off of this. So this would be my original. Sometimes it just says original. And those are the really easy ones. This one didn't, so it's a little trickier. And there's another trick at the end of this one too. But so now the only thing left, because I think I mentioned this, but we always have to have 100% and a variable in these percent problems. Only in percent problems, not conversions. So I have my 100%. My last spot has to be my variable. Now they cross multiply to solve. The trick on this one, though, is we are actually solving right here for the discount, not the sale price. So once they solve for the discount, because this is the discount, 25% off, they have to subtract that from 80. So the answer winds up being 60 for the actual answer. Here's another one. This is probably the last one I'm going to do. Maybe I'll set up both of these. So again, 100%. I know it's about percents. And as much as I would love to skip this step and not write that, I'm writing it so that they write it. Well, I know percentage has to be on top. So if they give me a percentage, there we go. I got half or one of my fractions filled out. That's a percentage sign. Now I just have to say, well, what is my original number, my starting number, my first number? The number that would have happened first on a timeline is what we say, because they did a timeline for one of their classes. My out of number, like any of those things. Well, there's original, but it's still kind of confusing. It doesn't really like 20% off of its original, but selling for this. That might tell me this is the selling price, so the after number. But here's an even bigger key. How do I do this? Let me try. I don't know why that's not working. Oh, there. Ah, there we go. It says right here what was, so that's your variable, what was the original price? So if I know 100 needs to match up with the original price, and I know the original price is my variable because that's what I'm solving for, that tells me. I haven't been doing this on this side. I probably should. It's not a bad idea to write your units over here also. These are in dollars. So percentages, dollars. If these were in something else, then you could put that measurement. Mainly the percents is the most important thing. So now I only have one other thing to fill out, and I have only one number in the problem. So that's how I set that one up and solve. Again, same thing down here. Pretty simple. 100%. Nope, didn't want to do that. Didn't want to do that. Oh, I don't even know how I did that. So 100%, they give me another percentage number. So I know 90 goes up here. So the tough one or tough part of this one is, well, which one of the nine, like, what is this number? What is this 72 number? Is that the full number of games? Is that the partial number of games? Because I need the full number down here. The original, the full, the total, what happened first. Well, tells me right here. How many total? Total is my keyword. Total means, and it's a variable because they're asking me how many total. So that's my variable. So again, this is probably one of the more difficult ones as far as the reading comprehension goes to understand what goes down here. So 72, and I can go back and just make sure they won 72 games and it's telling me that's only 90%. So that's not the full season. So that's a partial number. So 72, and again, I could write games. So I know it's about the games they won. So games, I'm just going to write a G down there. All right, so that's all the setup on the second thing. These were first two things were both on their quiz. Now on the new material we just went through, which they didn't have a great day on Thursday, and I think I sent a message out to at least one class, maybe even a couple, letting you guys know that they did a pretty good job on Friday. So a lot of them started to get it, so hopefully they'll do really well on this part. We learned a new way to do a different, same kind of problems, but just a different way to do it using a formula. So again, I don't know if they're going to be forced to use the formula, but the standard specifically says use the formula for percent change and percent error. So it might be that they give them a question where they have to understand how to use the formula in some way. So these are the two formulas we used. They're really the same formula. We take a number, subtract a number, and then we divide by that second number. We take a number, we subtract a number, and we divide by the second number. The big key is, as you might have noticed, well, they changed the words, but that's just a matter of them having different words in the word problem. You'll see when we do them. These things right here. These are called absolute value symbols. And the short version is, this is not actually what they are, but the short version is when I do the math inside here, like when I take this number and subtract this number, if it's a negative number, I need to make it positive. If it's already positive, then I'm fine. I just leave it as positive. So when they put the number into the calculator, they need to understand to do that. Or I gave them a short version. Percent error can never be negative. It just can't be negative. Like it's not a decrease, it's how far away from the correct value are you? Like that's literally what percent error means. How far away were you from what you wanted to get? So it doesn't matter if you were above it or below it. We just want to know how far away were you. That's why there's no negative to it. And then percent change can be negative. Typically, if it's negative, that means it's a decrease. If it's a positive, it's an increase. So they have this sheet. Again, they have the formulas. I'm going to just go ahead and do a couple problems, and this will be the last thing that'll be on their quiz. I don't even know how long we've been going. We did this one in class. They were supposed to do it. They do have to figure out what was the initial and what was the final, because that was in that formula. I'll go back to it. So initial and final. Initial is kind of like original. So again, the way I told them to find this initial value and the final value is think of a timeline. They did timelines in another class. The number that happens first in the timeline, that is your initial value, your original. The one that happens second is your final. Estimate and actual does not work that way, but typically they'll just say estimate and actual in the problem. So it's pretty easy for percent error. All right, so percent change. So I'm just going to set these up. They will have to set up proportions to solve, but then they can really solve it however they want. So percent change, this is what's happening first, and it's showing me it drops to this later. So original is up here. I'm just going to write, I'm sorry, initial. So this is my initial up here. It happened first in my timeline. It then dropped to this price. So that's my final. And I told them they can, oh, there are 3 steps for this, by the way. They need to label the numbers. So they need to say, this is the initial number. They can write initial equals 3.499. They can label it if there's a picture, as long as they label it so they know which one is which. Next to those numbers, right next to them, I said, write the formula. And again, they keep skipping these first 2 steps, and that's when they were messing up. The formula is final, and I said you can abbreviate this. So final, subtract initial, and then divided by initial. And if they do this, it's really hard to mess up if they label correctly. Everything's in one place. If they don't do this, they put stuff in the wrong positions. Again, not everybody, but even some of my strong students will occasionally put things in the wrong position if they don't follow all of these steps. So now I just put stuff in the right spot. My final, my F, is 3.079. So 0.79, subtract, and then my initial is 3.499. Hopefully gas does not go back up to these prices. Not the 3.499 especially. So then I divide by the initial. Well, the initial is again the 3. I'm going to kind of overlap that, but that's fine. 3.499. Now, I shouldn't say they need to set up, this is not a proportion. They're not setting up proportions in these. But they need to set the problem up like that. So they need to show me the labels for the numbers, initial, final, show me the formula with no numbers, then using the numbers, plug them in. Now to solve, some of them were still getting the wrong answer because I think they were typing it all into the calculator at once. And if you do that, it won't come out right. They need to solve the top part first. So do this top part, write that number, and then divide by this number down here. I don't have a calculator, so I'm not going to do it. I will do it really quickly with the one above. So again, what is my final? What is my initial? Well, what happens first in the problem? That's what I'm trying to figure out. That would be my initial, and what happens second would be my final. Well, let's see. So last month they won 8, this month 10. Well, what happens last then is 10. What happened first is 8. So that's my number. So I got my labels. Again, even though it's right down there, I want them to write it every single time, even the ones that have it down. Every year, especially like on a quiz, kids get in a hurry or they just want to try to finish super fast to show how much they know, and they mess up when they don't take all these steps. And again, I won't take off if they don't do it, but they will. Some of them will wind up messing up. So F is 10. Subtract, I is 8, and then 8. So now if I do the math, that's 2 divided by 8. And the answer was 25% increase. Now this would have been a negative number. They would have gotten negative something, which either they can write the negative number and just that's the answer, or they can write it as a positive and say it decreases. But again, percent change can be negative. It's percent error that cannot be negative. So now let's find a percent error problem, which I think is number 6. So they did these in class. This is actually a good one because it shows multiple numbers, and so it tells me this is how I know which formula to use. Percent error right there. So sometimes it is like this is a tricky one to say which one is the actual and which one is the, I'm sorry, what's the formula? Yeah. Actual and estimate, I think, is what's on their sheet. Estimate and actual, yeah. So here's what I told them in class. If it doesn't specifically tell you that, and I'll show you some where it does, but if it doesn't specifically tell you this is the estimate, this is the actual is what you have. Like, what do you have in your hand? What physical thing was produced what is the object that you have? What is the number of the object you have? Well, the measurement is what they have. This is the actual. They measured and got that. They measured and got that. They measured and got that. They wanted this, but that's not necessarily what they have. What they wanted was the estimate. What they actually measured were these. So again, a little tricky. Formulas pretty similar. I'll kind of abbreviate. Hopefully this isn't getting to be super, super long. I feel like I've been going forever. So again, actual is what they measured. It's what they got. I'm going to do, oh, this is three separate things. So I'm going to do lane first. So lane would be 26. That's his actual. They all want the same thing. So this is going to be the same for all of them. They wanted to get 25, or that's how long the nail was 25. So they were supposed to, if they measured correctly, get this. And this is a confusing problem. I won't make it this confusing. So now I write the formula. Estimated, subtract actual. And let me just make sure I'm putting that in the right place. Yeah, estimated, subtract actual. Huh. I think I actually have these backwards because that won't work. It should be subtract 25. So yeah, that's a tricky one. I will never give them one where it's that difficult to tell because I've told them in class whatever they have in their hand is what is the actual. Yeah. Oh, I'm gonna have to go back and change that for them. All right, so I'll change that for them, but yeah, the actual is what the nail is. So this one actually makes more sense that way. Hmm. Yeah, I'm gonna have to go back and change that for them. Oh, I hate it when it does that. Because percent error means what is the actual measurement? And even though they measured this, that is not really an estimate. That's what they got when they measured. We're still considering it to be we're considering it to be an estimate. They're measuring, but they're estimating, I guess, because they don't know for sure that it's 26. They weren't told how long the nail is, I guess. So this is the actual. So I actually have these backwards. So yeah, I need to cover that with them. So boy, and that could change by problem too. That's why word problems can be tricky. I will give them one. I'll show you one that I'll give them where it's a lot simpler for them to know which number is which. But yeah, this needs to be the actual that they should get. What should they get? And again, that could change because we did other problems where it wasn't like that. All right, so I'll have to go back and explain that to them, but this would definitely be the case for this one. We want to know what is the percent error from 25. I should get this, but I didn't, so how far off was I? Yeah, I got to come up with a way that they'll maybe be able to understand better. Oh. All right, so let's go to one where I'll show you exactly what percent increase, where is a percent error? These are most of them are percent change in the book. I know I saw one percent increase. Anytime it says percent increase or decrease, that's just percent change. Where in the world are all the percent error problems? Uh, Here we go. Percent error. So here you go. It tells you the prediction. So these would be the estimates. So it doesn't specifically say estimate, but it says, I'll probably just say estimate. So when it says something like that, that's more like what they'll need to know, something that's pretty obvious. So these are all predictions. If you don't understand what this graph means, don't worry about it. It won't be this hard either. So again, predicted. Here's a percent error problem. If they predicted there would be 1 inch, that's the estimate. Instead, they actually got 2.2 inches. So something like that is what I'll do for them. Because yeah, that other one was tricky, and we did problems, like I said, where using like that concept of it being a physical thing worked well, but then in that one, it didn't really work well. I have I was going to show you the example problems that we did that were a little more straightforward. Percent error. Oh, that's not even it. Oh, I'm going to send these book pages home too for the one we just did. Here we go, percent error. And this one, see, they literally said estimated, and this is what we did in class that was really much easier. Estimated it would be this, actual was this. That's what I'll do on the Wednesday quiz. Because the other one, they're going to really struggle to figure out which number is which on the other ones, I'm sure. I mean, they might have to do that on the FSA. So that's it. I'll correct that. If I know that was a little confusing at the end, it was even confusing to me. But I will go ahead and talk to them about that, and I'll give them a straightforward one on the quiz. So if you have any questions, though, if you're confused, just shoot me a talking points message after you get this or watch this.